3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
P3 tracking.
Plus 10
Magnificent
seconds.
liftoff of PSLV C-57 with Aditya L1 on board.
After the launch of Chandrayaan-3 by India, it was a proud moment for every one of us to watch the launch of Aditya L1 solar mission. So, hello everyone, after a long time, in this video we will be discussing about Aditya L1 solar mission. So, Aditya L1 is a solar mission by the Indian Space Research Organization. It was launched from Sriharikota, Andhra Pradesh. This marks the first time India is sending a mission to learn about the sun from its surface, called the photosphere, to its outer layer known as the corona. The mission is named after Aditya, the Hindu god of the sun. First of all, friends, let us know what is Aditya L1. Aditya L1 is a spacecraft that will be placed in a halo orbit around the Sun-Earth Lagrange point 1, that is called L1. L1 is a point in space that is located about 1.5 million kilometers from Earth. It is a stable point where the gravitational forces of the Sun and Earth balance each other out. This allows Aditya L1 to stay in orbit around L1 without using much fuel. The Aditya L1 mission was first proposed in 2008. The initial plan was to launch the mission in 2016, but it was delayed due to some technical issues. Now, what are the objectives of Aditya L1? First of all, it will study the structure and dynamics of the solar corona. It is the outermost layer of the sun's atmosphere, extending into the space and creating the solar wind. Secondly, it will help us to improve our understanding of the mechanism of coronal heating. The corona is incredibly hot, even hotter than the sun's surface, which goes against our conventional understanding of how temperatures change with distance from a heat source. This phenomena is known as coronal heating. Third point is that it will help us study the origin of coronal mass ejections. In short, it is called CMEs. CMEs are powerful bursts of solar wind, plasma and magnetic fields that are ejected from the sun's corona into space. These events can have significant impacts on space weather, potentially affecting satellites, communication systems and power grids on Earth. Next is, it will help us understand the connection between the solar atmosphere and the solar wind. By studying this connection, scientists hope to uncover how changes in the solar atmosphere influence the properties of the solar wind and how these changes in turn affect the space environment around our planet. Next objective is that Aditya L1 will also be studying the dynamics of space weather. Space weather can have a significant impact on the technologies and systems on Earth and in space. Understanding these dynamics of space weather is crucial for protecting satellites, spacecraft, and infrastructure on Earth. The Aditya L1 mission aims to contribute valuable data for improving our understanding of space weather processes and enhancing our ability to predict and mitigate their effects. Now, let us talk about the payload. Aditya L1 carries a suite of 7 instruments that will be used to study the sun. First is Visible Emission Line Coronagraph. In short, it is called VELC. This instrument will image the solar corona in visible light. Second is Solar Ultraviolet Imaging Telescope. In short, it is called SOOT. This instrument will image the solar atmosphere in ultraviolet light. Third is Solar Low Energy X-ray Spectrometer. In short, it is called SOLEX. This instrument will measure the X-ray spectrum of the solar corona. Fourth is High Energy L1 Orbiting X-ray Spectrometer. This instrument will measure the high energy X-ray spectrum of the solar corona. Fifth instrument is Solar Wind Composition Spectrometer. This instrument will measure the composition of the solar wind. Sixth instrument is in situ magnetometer. This instrument will measure the magnetic field of the solar wind. Last one is plasma analyzer package for Aditya. Its capabilities include analyzing solar wind, particles, electrons, and heavier ions with directions. In conclusion, Aditya L1 is a groundbreaking mission that will provide new insights into the Sun and its influence on the Earth. It has a comprehensive set of objectives that focus on studying various aspects of the Sun's outermost atmosphere, its influence on the space weather, and the fundamental physical processes that drive these phenomena. This knowledge not only enhances our understanding of the Sun itself, but also has practical implications for technology and systems here on Earth. That's all for today's video. Thank you for watching and comment below what are your opinion on this topic, and don't forget to subscribe this channel for more hot topics like this.